Welcome back to Year 11 Methods with me, Mr. Hanna. And in this video we're going to be talking about hybrid functions. Now hopefully you all know that a hybrid is kind of like a mix of two things at once. And that's exactly what it is here with a hybrid function. It's a mix of two functions at one time, or possibly more functions than two. So let's start off, so f of x, and then we use our big curly brackets to denote several functions. So let's say f of x is equal to x plus 1 for a particular domain. So let's say that domain is when x is smaller than 1. And then let's also say that a second bit of this hybrid function will be the function f of x is equal to 2x for the domain when x is greater than or equal to 1. So the function is made up of two separate functions. Each one is valid over a different domain. So if I sketch it, here's what it looks like. Let's get some axes going on, x, and this will be function of x up here. Okay, so obviously x being equal to 1 is an important point, so put that there. So for this graph, we're going to do x plus 1 for x is smaller than 1. So for all of this area out here, we're going to do x plus 1. So it's obviously going to go through the y-intercept at 1, and it's going to have a gradient of 1 as well. So it looks something like that, and it'll only go until 1. And here you can see that the x equals 1 is not included. So we'll use an open circle to represent not included. And it continues basically potentially forever backwards. Now we put in our second bit of the function as x being equal to 2x, and it's for when x is larger than or equal to 1. So when x equals 1, this graph equals 2, which is actually the same point that this would have been. And then it goes up with a gradient of 2, so it'll be like that. So I can put another point in just to show the gradient being 2. So let's put this point in with 2, 4. Shows the gradient must be 2 if this point here is 1, 2. Okay, now this bit does include the x equals 1 bit. So for this one, we'll color it in. Now you can see that this point 1, 2 would have been the point if we had have done the x plus 1 graph. So it turns out that this particular hybrid function is continuous. Continuous basically just means it's unbroken. The line just continues straight up without having any gaps in it around this point here. Okay, so that's a basic hybrid function. What we could do is change this hybrid function, because sometimes hybrid functions have more than just two functions. Sometimes they have 3 parts. So let me change this a little bit and say that it has a third part of, let's say, 2x minus 1 for when x is less than or equal to minus 1. And I'm just going to change the domain of this second one as well and say that it's between x equals minus 1 and 1, but not equal to. So if we had minus 1 in for this middle equation, we would have 0. So it means this point here is minus 1, 0. And that's where that middle equation stops. So we'll get rid of this bit. And because the minus 1, x equals minus 1 point is not included, we need an open circle there to show that that point is not included. Now to put in this second one here, the minus 1 term is included. So if we put minus 1 in here, we get 2 times minus 1, that's minus 2, minus 1. So that's minus 3 for this point here, minus 3. So it starts here at minus 1, minus 3, and it's got a gradient of 2, which is the same as this bit here. And it keeps going basically forever. So now, this new hybrid function with 3 parts to it, this bit here is not continuous. So it's not continuous over here. Or if you want, you can say it's discontinuous. Same thing. Okay, so that's basically all you need to know about hybrid functions. Very last thing I'm going to do is show you how you can do these on your graphics calculator. I mean your CAS calculator. Okay, so we'll open up a calculator page and we're trying to define this hybrid function, and we're going to call it f of x. We could call it anything, but I'm just going to call it f of x. And I'll make it equal to this hybrid function. Now to get this big curly brackets, or this big brace, you need to go into this button here where you can see the braces. Now, there's lots of options to choose from. We need to choose the one that's got 3 bits to our function, because we'll see we've got 3 bits, and the one with the commas to show the 3 different domains. So it's important that we choose the right one, this one here. Now it asks us to choose how many different pieces to this function are there. And obviously there's 3 different pieces to this hybrid function, so make sure we've got 3. If there was 4, we'd obviously click up to 4. But we'll stick with 3. Now we've got to put in our function. So put in our function. So we have 2x minus 1, and now we have to put in the domain that that's valid for. So that one's for when x is, now remember this button over here, so press Control to show all our different greater than or less than symbols. So it's for when x is less than or equal to minus 1 for that one. Oops. Then our next part of the function is x plus 1. Valid for x being between minus 1 and 1. So x is greater than minus 1, but less than 1. And the final part is 2x when x is, when x is, hey, across we go, when x is larger than or equal to 1. So go put all that in, press enter, it says done, so it's defined. This hybrid function stored in the memory. So now if we open up a graphs page, we can display it just by typing in the function of x, which is what we called it. Enter. Now there we go, that's exactly the same function that we had graphed earlier. So if I just shrink, so there it is, that's exactly the same as here. The only difference is it doesn't show you the open circle here and the closed circle down here, because the CAS calculators aren't able to do that. So you need to be very confident that you can do that on your own. That's it for hybrid functions. See you later.